So now I explain the parallel line development for cylinders. Then I explain how we develop a cone. So do you think whether these both type of developments are doing in the same way or in a different way? I told you development of prism and pyramids are parallel line development. Okay. Now what is the difference between development of a prism and a cone? Here you are unfolding this prism for doing its development. The development is taking place parallel to the axis of the solid. Whereas here, the unfolding is not taking place parallel to the axis, where you can see it is taking place in a radial way. So this type of development is called as radial line development. For example, if you take the pyramid, see the development is taking place in a radial fashion, not parallel to the axis of the solid. So this type of development is called as radial line development. So these are the two basic types of development: parallel line development for prisms and cylinders, radial line development for cone and pyramids. Then there is another type of development which is called as the approximate type development. This is usually used for spheres. Then triangular type development, that is used for some triangular prisms or like that. It's not our point of view, or it's not our concern. Okay. Now, how will you draw the development of a pyramid? See, first of all, you draw the plan elevation. Will it be same as that of the development of a cone? No. Here you can see some difference is there. We will be drawing this arc. Divide this arc into 4 equal parts to get a square pyramid, pentagon, 5 equal parts. Then join these arc points with straight lines. We'll be getting the development. Okay. So I'll be drawing this plan elevation first. Okay. Then how will you do the development? For cone, with O dash as center, A dash as radius, draw an arc until it reaches the arc length. That means it reaches the angle theta. Divide that into 80 equal. Will it be applicable to pyramids also? No, because for cone, you can see that this line OA is parallel to XY line. So this measurement is true measurement of that slant edge. Okay, I told you development will be always represents the shape which is having two dimensions. So now check the slant edge OA and this length O dash A dash. Is it true length? No. Why? O dash A dash is inclined to the horizontal plane, whereas OA is inclined to vertical plane. So this line OA is inclined to both the planes, so neither the plan length nor the elevation length will give the true length. Okay, so how will you get the true length of the line OA? And you know that for drawing this arc, this radius should be equal to the true length. How will you find out the true length of the line OA? Suppose this point A is here. How will you find out the true length? You rotate it with OA as center, OA as radius, rotate it, make it parallel. Now project it, you will get the true length. The same thing that will be applied here. With OA as center, OA as radius, rotate this machine. So make it parallel. Since this line is parallel, O dash A dash will use the true length. How will you get the true length? Project it up. You project this point up to the XY line. Now I'm projecting this up to the XY line. Now you can see that this point will be capital A, and you will be getting, if you join OA, this is the true length of the slant edge O dash A dash. Now I got the radial measurement as radius as true length with OA as center, OA as radius, draw an arc. Here there is no need of finding the angle theta. Why? Because we know each and every arc length. What is arc length? AB. Next point should be B. What is the true measurement of AB? That is the base measurement. For example, if this is 20, take A, 20 mm radius, cut an arc on this. You'll get the point B. This is 20. BC is again 20. You get C. D, the final point will be E. Okay. Join OA, OB, OC, and but this is not the development of the pyramid, this is the development of a pole. How will you transform this into development of a pyramid? Join these sides with straight lines. Then only this becomes development of a pyramid, because you can see that edges are straight in the case of pyramids. Okay. Now this is very important. The true length measurement is very important in the case of development of pyramids. Suppose if you are drawing the hexagon, develop it like this. You can see that O dash, A dash, OE. This OA is already parallel to the XY line, so this is true length. Okay. Now I'm drawing the same hexagon like this. Okay. Now we can see that this O dash, A dash is not equal to true length. Now to find the true length, where is on the line? Rotate this OA measurement, make it parallel, project it. Then this becomes the true length. Draw an arc with OA as center and OA as radius. Take the base measurement, since it's a hexagon, cut 6 arcs on this line. Okay, 1, 2, 3, 4, 5, and 6 will be getting B, C, D, E, F, and A. Join it, all the points with straight lines. Then join it. You get the development of it. Thank you.